Hello everyone, our lesson today is lesson 1 in unit 4 geometry. Scalars, vectors and directed line segment. First of all, we talk about scalar quantity and vector quantity. So we have here scalar quantity and vector quantity. Scalar quantity we talk about or determined by a magnitude like length. If we talk about your length is 170 centimeter. So we talk about only the magnitude. We don't say your length is 170 centimeter in the direction blah blah blah. So we talk only we say only the magnitude of your length. So scalar quantity like length, like mass, like time, temperature, volume, distance, and so on. Okay? What about vector quantity? Vector quantity determined by the magnitude and the direction. We talk about magnitude and direction, like force, velocity, displacement, and so on. So we have here scalar quantity and vector quantity. Scalar quantity determined by only the magnitude. Vector quantity determined by the magnitude and the direction. Here we talk about directed line segment. If we have here line segment AB, we said before line segment AB have starting point and ending point. What about directed line segment? We denoted the directed line segment by AB. This symbol, it means directed line segment. Okay, here we have three conditions to set the line segment AB is directed line segment. First, we determined by we have starting point, ending point, and the direction from starting point to ending point. It means here, if we have here the directed line segment AB, it means A is the starting point, B its ending point, and the direction from A to B. What about BA? So here we have AB, its difference to BA. Why? Because here we have starting point B and ending point A, and the direction from B to A. So we said AB not equivalent to BA. Here we talk about vectors, not say equals, we said equivalent. So we have here AB not equivalent to BA. If we said AB equivalent to BA, so we must write negative. Why? Because we have two directions. Okay? To set the two directed line segment equivalent, we must have the same length or the norm, and must have the same direction. So to set the two directed line segment equivalent, we must have two conditions. They have the same length or the same norm, and they must have the same directions. We have some examples. Number 1, show whether the two rays have the same, opposite, or different directions. First of all, if we have two straight lines parallel, so we have two ways. They have same direction or opposite direction. If they have same direction, so they are equal in the same direction. So here we have parallel, same direction, or opposite. If they are in the same direction, so they are same. If they are in different directions, so it will be opposite. Okay, if the two straight line not parallel, so they are different direction. Okay, again, if we have two straight line parallel in the same direction, we call the same direction. In different direction, we call the opposite direction. Okay, if the two straight line not parallel, so they have different direction. We have some examples. Number 1, AB. So starting point A and ending point B. So the direction here will be like this. And DF, D starting point here and DF here. Okay, so they are opposite direction. And the two straight line parallel. So here we have opposite direction. Why? Because they are parallel and different direction. So they are opposite direction. Number 2. Here AB also in this direction. XY here, XY here. The straight line AB and the straight line XY not parallel, so they are in different direction. Why? Because they are not parallel, so they are different direction. What about number 3? Here CD, it means we have this direction. EB in this direction, so they have the same direction and they are parallel, same direction and parallel, so they have same direction. The last one, ZY in this direction, ZX also in this direction, and they are on the same straight line, collinear, coincident, so they are parallel. If we have on the same straight line or constant, it's a special case from parallel, so they are in the same direction, so they have same direction. Another example, number 2. Write the direction line segment which equivalent to. We said before, the directed line segment we determine by 3 points. Number 1, starting point, ending point, direction from starting to ending point. And we said to set the two directed line segment if equivalent if we have the same length or the same norm and they have the same direction. So we want to get the equivalent directed line segment to BX. Here in this figure we have X midpoint, Z midpoint and Y midpoint. So here we have XZ is line segment joins between two midpoints. We said in first preparatory is equal half the third side, which is half BC and parallel to BC. So here we have XZ equal to CY equal to YB. Okay, so here BX, the direction of BX in this way, and here the starting point B and ending point BX. So we search for the directed line segment have the same length, have the same norm and the same direction. So have the same direction, so it must have parallel. Why? As we said, two straight line parallel, so they have the same direction. So we search for BX parallel for what? And have the same norm, have the same length. So here BX parallel to ZY. Why? Because we have here Z and Y two midpoints. So that ZY parallel to third side. Okay? And here start from B as a starting point, so must start from Y as a starting point. So here we have YZ. So the equivalent of BX is YZ. And also, as we said, on the same straight line, because we have special case of parallel. So start from X and A on the same straight line of BX, which is XA. Okay, so we have YZ and XA. Number 2. Here CY. Okay, CY here is the starting point and ending point, and this is the direction. On the same straight line we take YB. YB have the same norm, have the same length, and its direction equals the direction of CY. So we have here YB. And here we talk about parallel. CY parallel to what? The ZX in the same direction, so we start from Z to X. So the vector ZX. Okay, here AZ. Here is the direction of AZ. So in the same straight, on the same straight line, we said ZC. So we talk about ZC. And also AZ parallel to what? Parallel to XY. Why? Because we have here X is a midpoint, Y is a midpoint, so XY parallel to AC. So here we have also XY. What about XY? Here XY, the direction of XY, starting from X to Y, this direction. Here XY parallel to what? Parallel to AC also, as we said in the previous example. So XY here we talk about AZ and also ZC. So we talk about AZ and ZC. Number 5, XZ. Here XZ, the starting point here, and to Z, so the direction will be here. Here XZ parallel to what? Parallel to BC. So we talk about BY and YC. So BY and YC. The last one, ZY. Here ZY in this direction. So we talk about ZY parallel to AB. So we talk about AX and XB. And XB. Okay, thank you.